Today we're going to be talking about bisectors. If you don't already have notes out, please get them out. Either you're taking notes on your own piece of paper or you have printed out the blank notes. The blank notes are always found at the bottom of a week, or there is a actual section that just calls blank notes so that you can follow along. It is expected that you're taking notes on these lessons so that you can get in the habit of doing that when you come back to class. Not to mention, it is helpful. It is a reference for you to look at. You can't be watching the video over and over again. So this is a quick reference of you having the information in front of you. So section 1.3 and 1.4 bisectors, it's two sections, but it's one topic, so we just put them together. And we're going to look at segment bisectors and angle bisectors. Today is the 31st of August, so August 31st. It's the day that 31 Flavors puts their ice cream on sale, just in case you didn't know that. So what we're going to look at are, first off, segment bisectors. So the definition of a segment bisector is any line, segment, ray, or plane. We don't tend to work with the plane because that's three-dimensional. We tend to stay in two-dimensional. So if you have some kind of line, segment, or ray, something that's actually intersecting a segment at its midpoint, then you're going to have a segment bisector. I'm going to move that just a little bit. Okay. So if we have a segment, say segment AM, sorry. How about segment AB? I like that one better. So segment AB, and somewhere along the line, a line passes through the midpoint. That line is the bisector. Now you'll notice it says line, segment, or ray, because we know if we took off the arrows, it would be a segment. It'd be the same thing. It would be bisecting segment AB, or a ray, same thing. So just as a review, what's a midpoint? A midpoint is a point that divides a segment into two congruent segments. And so let's review congruent. Congruent means to have the same shape and same measure, and the symbol for congruent is the equal sign with the tilde, so it has a little squiggle over the top of it. So if you have a segment that has a midpoint, it's going to make additional segments, and those segments are going to be congruent to each other. So here's a statement: line L bisects segment AB at point M. So here's our picture. Here's segment AB. Here's line L bisecting through point M. So geometry is all about the logic, what comes next. And how do we know what comes next? We're going to use the definitions we already know. So what does a bisector make? Or what happens in a bisector? A bisector leads to a midpoint. So if you know that line L bisects segment AB, then you now know that point M is a midpoint. Okay. So then what comes next logically? Well, what does a midpoint do? A midpoint makes segments that are congruent. So logically, if you see the word midpoint, you now know you have congruent segments. So let's look at our picture. So M's our midpoint, so our two segments are segment AM. So segment AM is congruent to segment MB. And remember that congruent can be marked in the picture through tick marks, so as long as they have the same number of tick marks, they're congruent. And then logically, what do we know about congruent? Well, congruent means same shape, same measure. So this shows same shape, but now we need it to show same measure. So just as a reminder, the segment symbol is the actual item, the actual segment, the thing you can play with. And in the case of a segment, we actually remove the stick to talk about the numbers or the measures. The other reminder is if it's in red, it's not required to be written in your notes, It's just a good idea to add on there. So let's look at some examples about bisectors and midpoints. So line L bisects the segment. So we know there's a bisector. We know a bisector means there's a midpoint. So we know that W is the midpoint. But we're going to actually go down to the next step. So since we know that we have something being bisected, a segment being bisected, we know there are two segments that are congruent. So we know that segment XW is congruent to segment WY. But if you look at the question, it says find the length of XY if you know that the length of WY is 3/8. So this is about measure and length. So logically, if two segments are congruent, their measures are equal. Now at that point, I can deal with the question because now I'm talking about measures. So the length of WY is 3/8, so I'm going to substitute. So if I just bring that down, oh look, the length of XW is 3/8, which should totally make sense. Because if these two segments are congruent, they should have the same measure. Great, I'm done. No, I'm not. The question was find the length of segment XY. So segment XY is this whole thing right there. So that means that we need to go back in our memories. How do you find an entire segment? You add the two smaller pieces. So the entire segment XY has a measure of segment XW plus the measure of segment WY. So this took us back to the segment addition postulate from the beginning of the chapter. So we're going to substitute. We do not know the length of XY because they told us or asked us what that was. So the length of XW we figured out was 3/8. The length of WY was 3/8 because that's what they gave to us right here. So when adding fractions, you add the numerator and keep the common denominator. And then there's this lovely rule in mathematics that you must reduce. Since they're both even, I'm going to divide by 2. So the length of XY is 3/4. So now this is the point in the video that doesn't really match your notes. You'll notice that my example is 0. If you look in the notes, you don't have an example 0 because this is an example that I want you to just put down your pencil and I want you to just watch what I'm doing. It says find the length of AM, so we're going to be looking for a measure, and we are told that M is the midpoint of segment AC. Now, remember, they could have used a bisector in there as well. They could have said that segment AC was bisected. They're going to produce the same work. So a midpoint means that there are two congruent segments. They were even nice enough in this picture to tell us which two segments. So segment AM is congruent to segment MC. And that's where we're going to start because we always start with the geometry. Always, 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 always. Okay. So this question is about measure. So what else do I know about congruent segments? I know their measures are equal, so I'm going to convert to their measures are equal. And so now I can substitute because this is what I actually know. I know the measure of segment AM is 6x minus 11. And I know the measure of segment MC is 10x minus 51. Now algebra is going to kick in. This was not an algebra problem to start with, it was a geometry problem. So we're going to do geometry and then convert into algebra. So I need to isolate the x. I need to make sure all the x's are on one side and all the constants are on the other. I'm going to subtract 6x from the left, giving me negative 11. I'm going to subtract 6x from the right side, giving me 4x minus 51. I'm going to write down what I haven't done something to. Now I'm going to add 51 to the right, and I'll get 4x. And when I add 51 to the left, I'm going to get 40. I've isolated the variable, but it's not completely alone yet, so I'm going to divide by 4, so x is 10. Okay, so now I'm done. No. Remember to always go back and look at the question. The question is, what is the length of segment AM? So I'm going to write that down. The length of segment AM is 6x minus 11. Why am I writing that down? Because this question isn't on my work. This question is on the computer screen, or this question is on my worksheet. It's not on my sheet of work, so I'm going to have a good conversation with whoever looks at my work, and so I'm going to write that down. Now, this isn't really finding it yet because I need to substitute in the 10 that I just found. So order of operations says do 6 times 10, and then just write down everything else because I'm not doing it yet. And now finally the length of AM should be 49. Now how do you double check your work? Well, we just found out that the length of AM was 49. If these two are congruent, this should be 49 as well. So let me just double check in my head. 10 times 10 is 100, minus 51. Yep, that's 49. Yes, they check. So now's the time to pick up your pencil again. We're going to go ahead and do example 2. So point S is the midpoint of segment RT. Find the length of RS. So midpoint means congruent. So which two segments are congruent? Segment RS and segment ST. So segment RS is congruent to segment ST. Now I know some of you are already thinking, man, I don't want to do that. She's not watching what I'm doing anyway. Mr. Murphy's not watching what I'm doing. Mr. Finney's not watching what I'm doing. Mr. Keeney's not watching. I mean, like, nobody's watching me, so why don't I just... Mrs. Thompson's not watching it. You know, just not watching you. So the question is, why do you do it anyway? Because the lessons that we're doing now are prepping you for future lessons. And in a future lesson, that is a requirement to understand what happens logically in order. So practice it now. Midpoints cause congruent segments. Congruent segments have equal measure. So that's all the geometry. Now we're talking about equal measures, so I'm going to substitute. The length of RS is 5x minus 2. You can see that right there. The length of ST is 3x plus 8. So they're equal. So since the segments measures were equal, then the numbers they gave us were equal. I'm going to subtract 3x, so it's going to give me an 8 on the right, and when I subtract 3x over here, I'm going to get 2x minus 2. I'm going to add 2, giving me 2x, and when I add 2 to 8, I get 10. So I'm on my way. So I'm going to divide both sides by 2, and x is 5. I'm going to move that up just a little bit because I'm starting to get scrunchy. So am I done? Does it say find x? No, it says find the length of RS. So I'm going to have a good math conversation. I'm going to tell my reader what RS was equal to start with. So the length of RS was 5x minus 2. We just found out that x was 5, so now we have 5 times 5 minus 2. Order of operations, so multiply first, so 25 minus 2. So the length of RS is 23. Again, you can double check that. If I just figured out this was 23 and they're supposed to be congruent, then this should be 23 as well. So 5 times 3 is 15 plus 8. Yep, 23. It works out. So one of the biggest things that you're going to find out over time in this class is that we tend to do a lot of things that seem similar but for different reasons. And the one thing that you're going to see that happens a lot is that the two measures are equal. You're going to see that all throughout today's lesson, and you're going to see it a lot throughout this semester and next semester. Things tend to be equal more so than anything else, so that's a key point to remember. Things tend to be equal more than anything else. Okay, so now let's go on to angle bisectors. So the definition of an angle bisector is a ray, and that's it, that's all they say. A ray that divides an angle into two angles that are congruent. So the question is, well, why can't this time I say line? Well, if I drew it like this, it would definitely be a line, but they're still only taking the part of the line that's on the interior of the angle, because it's only the interior of the angle that's getting bisected. So that's why they'll say ray instead of line or segment. So ray BD bisects angle ABC. So here's my angle ABC. Here's my ray BD, and it's bisecting it. It's cutting it into two congruent angles. So we know in the case of a segment that gets bisected, the congruent marks are tick marks. So the same number of tick marks makes the segments congruent. It's a little hard to put tick marks in this diagram. So what we put is we put arc marks. So as long as there's the same number of arc marks, then those angles are congruent. Okay, again, geometry is about logic. So what comes next logically? Well, we know from the definition that an angle bisector, this ray right here, will cause two angles to be congruent. So we need to know what those two angles are that are going to be congruent. They're basically the upper portion and the lower portion. So the upper portion is angle ABD. So angle ABD is congruent to the lower portion, which is angle DBC. Angle DBC. So a bisector in the case of an angle makes two congruent angles, and then the next logical thing is congruent angles have the same measure. So remember that when we talk about an angle, we aren't going to remove something to talk about its measure. We're going to add something on. Segment, we remove the symbol to mean measure. Everything else we learn about measure is going to be indicated by adding the M. So the measure of angle ABD is equal to the measure of angle DBC. So if you see the word bisector, you know all of these other things. And that's important because, again, we're going to get farther and farther into this class, and I'm going to ask you, well, what else do you know? What else do you know? What else do you know? That is going to be a common theme, and so these are the things you need to be aware of through the definitions. So if you have not reviewed your postulates or definitions in a while, because this is week 5, and we've had them in week 2, 3, and 4, you need to go back and review those. Okay, so here's our example. Ray BD, that picture is pretty bad, sorry about that. Ray BD bisects angle ABC. We're going to find the measure. So we need this to be about measures, yet bisectors cause angles to be congruent. So if angle ABC is being bisected, the upper part is congruent to the lower part. So angle ABD is congruent to angle DBC. But our question's about the measure. So what else do we know? We know bisectors make congruent angles, and we know that congruent angles have the same measure. Whoops, keep trying to make mistakes here. That's one of the biggest reasons I suggest you use a pencil, so you can erase it. Okay, so now that we're talking about measures, we can substitute. So the measure of angle ABD is x plus 20, and that's equal to the measure of angle DBC, which is 3x minus 4. And now we're going to kick into the algebra, because remember, you're always starting with the geometry. And the geometry is coming from definitions and postulates, and we're going to talk about other geometry terms here in the next few days. So I'm going to subtract the x from the left, giving me 20 equals, subtracting x, 2x minus 4. I'm going to add the 4. So on the right I'm going to get 2x. When I add the 4 on the left, I get 24. So 24 equals 2x. My x is now isolated, so I need to divide by 2 on the left and the right, so x is 12. But wait, it says find the measure of angle ABD. The measure of angle ABD is x plus 20. Oh look, I found it, I'm done. Like, why did I have to do all that other stuff? Well, because we know that that doesn't really mean find it. It needs to actually be a number. And so if you had said the measure of angle ABD was x plus 20 and stopped, you aren't actually finding the true measure. You're finding an expression for that measure, but not the measure. So that's why we have to go in and find the x so that we can substitute the correct value of x. And so the measure of angle ABD is 32 degrees, because angles are always degrees. And just like the segments, you can double check your work. If we just decided this was 32 degrees, this should be 32 as well. So let's double check that. 12 times 3 is 36. 36 minus 4, yep, that's 32. So that does check. Please go back and watch the video again as much as you want. Pause it, look at it, rework it. Make sure that you're emailing your teachers if you need any extra help or if you're asking for a Zoom session. It really is helpful for us if you tell us what period you are in, because that does not show up in your emails, and it does actually help us. Also, please tell us what day you're asking about and what question you're asking about. And it is best that you don't send an email that says, I don't get this. Please provide us with enough information so that we can get you a good answer immediately. If you just say, I don't get this, we have a really hard time answering you. You'll have to get another email from us that basically asks, what have you done in the question? Where in the problem are you actually having the question is coming from? So please try to be as detailed as possible in your emails to us so that we can answer you the first time.